All right, eighth graders, we're going to start to get you into chapter 5, which is all about solving systems of linear equations. And here in chapter 5, you're going to explore many different ways of solving systems of linear equations. Essentially, when you're solving a system of linear equations, is you're given two lines, okay? And the first job is always to make sure they're in slope-intercept form. These two are in slope-intercept form. So that's the way that we like them. It makes it a little easier, one less step. But then the job is to figure out what is the intersecting point, okay? Because they're not the same line. So our job is to figure out what the intersecting point is of that line. At what ordered pair do those lines cross each other? And I do that once everything's in slope-intercept form, which it is here. Remember that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. They already have y isolated here, so these two are already in slope-intercept form. So what I do is I set up an equation that says x minus 1 equals negative x plus 3. So I make them equal. And then what I want to do is I want to isolate the variable. So essentially what I'm going to do is I'm going to add x to both sides to get rid of this. Add x to here. That gives me 0 there. And I'm going to add x over here because whatever I do to one side I have to do to the other. And so those are like terms. That gives me 2x. Remember the 1x plus the 1x is 2x. I need to get a 0 on both sides. So here I have negative 1. And to get to 0, I'm going to add 1. But if I add 1 to this side, I have to add 1 to this side. And I know that 3 plus 1 is 4. So that leaves me with 2x equals 4. Well, if 2x equals 4, I do 4 divided by 2, and that tells me that x equals 2. Then I have to go back to my original equations and plug in 2 for x. I decide where I want to plug it in, and I'm going to plug in 2 right here. If x is 2, that it says here, then I'm going to do y equals 2 minus 1. Well, 2 minus 1 is 1. So that tells me that y equals 1. And I can just show you on this one, since x is 2, if I do negative 2 plus 3, negative 2 plus 3 is also 1. So it works for either equation. X is 2, y is 1. The solution, you write it as an ordered pair, 2, 1. Let's go to this one. Y equals negative 5x plus 14. Y equals x minus 10. Well, they're already both in slope-intercept form for us, so that helps. So once again, I can just make them equal. Negative 5x plus 14 equals x minus 10. All right, so I'm thinking, well, okay. I'm going to go ahead and I'm going to add 5x to this side. All right, and I'm going to add 5x. Negative 5 plus 5 gives me 0. I have x, and if I add 5x to this side, remember that there's a 1 here, so 1x plus 5x equals 6x. I need a 0 on both sides. I already have a 0 here, so I need to make this 0. This is negative 10. I make that 0 by adding 10. Negative 10 plus 10 is 0. And if I add 10 to this side, I have to add 10 to this side. 14 plus 10 is 24. Well, interestingly enough, 8th graders, most of the time these numbers are going to work out pretty well for you. And here you've ended up with 24 equals 6x. So to solve for x, I have to divide 24 divided by 6. 24 divided by 6 is 4. So that tells me that x equals 4. But now I need to plug this value in because I also need to solve for y. If x equals 4, and I can use either equation, x here is already by itself, so I'm going to plug in 4 right here, and it's going to tell me that y equals 4 minus 10. Well, 4 minus 10 is negative 6. So that tells me that y equals negative 6, which means that my ordered pair, my solution to these linear equations, the intersection point is 4, negative 6. Now, your directions in your book, 8th grade, are going to probably do this a little bit differently. They're going to have some graphing and some things going on. My recommendation here for you right now, don't worry about that. Just solve them this way. Show your workout, find the intersecting point. Graphing can cause a lot of confusion, and so we want to solve them algebraically. All right, well, let's look at some more. All right. This next one, in fact, we're going to go to this one right here. This next one tells us that y equals negative 4x minus 7, x plus y equals 2. Well, this top one is already in slope-intercept form. I'm going to give us a little more space. But this one here, this x plus y equals 2, is not in slope-intercept form. So I need to get this in slope-intercept form by setting it up as y equals, and I have to get this x over to this side. I get the x over to that side by subtracting x from both sides. So if I subtract x from this side, there's nothing there. In fact, I'll even show you. We'll go minus x, that gives me nothing. But if I do, there's nothing over here with x. So I'm still subtracting x. So that is actually just going to leave me with a negative x. It's like 0 minus x is a negative x. And then my plus 2 has to become part of my problem. So now I have two equations in slope-intercept form. So I'm going to come over here. Negative 4x minus 7 is equal to negative x plus 2. Negative x plus 2. Well, I have a negative x here. I want to make that 0, so now I'm going to add x to both sides and make that 0. Here I have a negative 4x plus a 1x. Well, negative 4 plus 1 is a negative 3x. I have to get a 0 on both sides, so I have to get a 0 on this side. This is negative 7, so I have to add 7 to make 0. But if I add 7 to this side, I've got to add 7 to its like term on this side, and 2 plus 7 is 9. And amazingly, once again, 8th grade, you see how that works. Negative 3x equals 9. And then to solve for x, I just have to do 9 divided by negative 3. Well, 9 divided by negative 3 is going to tell me that x equals negative 3. And when I go back in and plug in my values, okay, I'm going to go to this one that's already in slope-intercept form. Y equals negative 4x minus 7. Well, I know that x equals negative 3. A number right next to a variable means multiplication. So this is negative 4 times a negative 3, and a negative 4 times a negative 3 is 12. So that gives me 12 minus 7. Well, 12 minus 7 is 5. Y equals 5. And if I want to set that up, I can set that up, you know. I can go y equals negative 4 times a negative 3 minus 7. But then I just get, like I said, y equals 12, because negative 4 times a negative 3 is 12, minus 7, which equals 5. My ordered pair, my intersecting point, is negative 3, 5. All right, we're going to look at just one more, and then we're going to go ahead and move on. Let's look at this one with the fractions, all right? And so get a fraction in here and have to get one that's not even y by itself. So this is a good one. Let me erase this here. 1/2 x plus y equals a negative 6. 6x plus 2y equals 8. Well, first of all, with this y is by itself, but I'd have to get rid of the negative 1/2 x by subtracting 1/2 x from both sides. If I subtract 1/2 x from this side, that's going to give me 0. I have nothing over here with an x that's a like term. So I'm essentially doing nothing minus a half x. So that leaves me with y equals negative 1/2 x minus 6, because it's a negative 6. And 1/2 x minus 1/2 x is 0. There's no like term over here, so it's 0 minus 1/2 x, which gives me a negative 1/2 x. Now this one here is a little bit interesting, because not only is it not in slope-intercept form, there's a coefficient with the y. So first of all, I want to isolate the 2y. Get that by itself. I got to get rid of the 6x, so I'm going to subtract 6x from both sides. Once again, there's nothing over here with an x, so that's going to leave me over here with negative 6x. Then I have to include my plus 8. Now to get, in this situation, 2y by itself, I'm going to divide everything by 2. 2y divided by 2 is y. Negative 6x divided by 2 is a negative 3x, because negative 6 divided by 2 is negative 3. X becomes part of it. Plus 8 divided by 2, well, 8 divided by 2 is 4. So in slope-intercept form, I end up with y equals negative 3x plus 4. So that becomes my other equation, negative 3x plus 4. Now I have to go through that process. Now that everything's in slope-intercept form, I have to go through that process. So I have to make them equal. Negative 1/2 x minus 6 is equivalent to negative 3x plus 4. Okay? So if I come over here, I want to get rid of this negative 1/2 x by adding 1/2 x to both sides. That gives me 0. When I have negative 3 plus a 1/2 x, that actually gives me a negative 2.5 x. I need a 0 on both sides, so I'm going to come over here, positive 4. I'm going to subtract 4. That's going to give me 0, but if I subtract 4 from this side, I have to subtract 4 from this side. That gives me negative 6 minus 4 is a negative 10. So now I've ended up with negative 2.5 x equals negative 10. So essentially I'm doing negative 10 divided by negative 2.5. So I'm going to give us a little space here so I can show my scratch work. I'm essentially needing to do negative 10 and divide that by a negative 2.5. First of all, as an 8th grader, I need to realize it's a negative times divided by a negative, not times, sorry. 2 negatives, I'm going to have a positive answer. So I'm going to just forget that the negatives are even there. Going to make everything a fraction. 10 over 1 is going to be divided by 2 times 2 is 4, plus 1 is 5. 5 over 2. Now when I divide fractions, remember the first one stays the same. Division becomes a multiplication. You make the reciprocal of 5 over 2, which is 2 over 5. I can't cross-check a 1 and a 2. Nothing besides 1 can go into both 1 and 2. I can cross-check a 5 and a 10 by dividing by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. I end up with 2 times 2 is 4. 1 times 1 is 1. 4 over 1, well, I know that 4 over 1 equals 4. So that tells me that x equals 4. I've now solved for x. X equals 4. Well, I'm going to go back and plug that into one of my equations in slope-intercept form. This one looks a little bit easier because I really don't want to have to work with fractions. So it's going to be negative 3 times 4. Since x equals 4, it's going to be negative 3 times 4, because a number right next to a variable means multiplication. Well, negative 3 times 4 is negative 12. Negative 12 plus 4 is negative 8. So once again, negative 3 times x, x is 4, so negative 3 times 4 is negative 12. But negative 12 plus 4 is negative 8. That tells me that y equals negative 8, and that the intersecting point of those two lines is 4, negative 8. That's the process you're going through today on your assignment, 8th graders. Have fun. Rewatch the video if you need to. Hope it helps. Talk to you later. Bye.